Good morning, dear students. We are discussing the treatment of water. We are discussing treatment of water, where we have seen the process of sedimentation. In that, we were seeing the design of sedimentation tanks, principle of sedimentation, and all. Before that, have a look on this particular introduction slide. This is the overview of treatment plant, partial overview of treatment plant. See, from the intakes, through these treatment plants, water will be supplied to the consumer. Understand? See, intakes we have seen, there are different types of intakes like reservoir intake, lake intake, canal intake, river intake. We have seen the intakes are meant to collect the water. After collection of water, the collected water will be supplied to the consumer after the treatment. In that treatment, we have seen the first step, sedimentation. Sedimentation here, we are not doing anything in the process, in the step by name sedimentation. We are allowing water without disturbing for a period of time. By doing so, the particles whose specific gravity is more than the liquid will settles bottom. After a period of time, the settled particles will be taken off and the water will be sent to the next unit. See, when we were discussing the specification to construct these treatment plants, the first specification is all the units must be constructed in a sequential order of treatment. First point. And the second point, all the units must be constructed at an elevation where the water flows into the next unit based on the gravity. Second point. Third point, proper designing or a proper plan has to be adopted before starting off this treatment plant for various units to be constructed in that plant. Next point, there should be accessibility or feasibility for future expansion of this treatment plant, and sufficient place has to be there even to construct staff quarters. Clean atmosphere has to be maintained in and around the treatment plants. These are the specifications we have seen. Similarly, we have been discussing these type of specifications from the beginning. We have seen the specifications for reservoirs to be constructed. We have seen the specifications for intakes to be constructed. Likewise, whenever these type of units as part of water supply engineering, we came to know different specifications. To be adopted for constructing various units, maybe intakes, maybe reservoirs, or else it may treatment plants. Now, hope you understood the basic layout of treatment plant. See, after that, see here, next, once we have an idea of these treatment plants, we'll move to the topic where we left in the previous class. We were discussing sedimentation plants, and More particularly, we are at circular tanks. See, these circular tanks are not suitable. The first point is for plain sedimentation. In the plain sedimentation, what happened? See here, these rectangular sedimentation tanks are more suitable for plain sedimentation tank, where the water is allowed to cross these baffle channels while the water is passing from these units. Slowly, by gravity, the weighted particles will settle on the bottom. As the bottom is slopey towards the center, which is connected to a sludge pipe, we have seen like this, the settled particles will be sent off. Understand? Now, circular tanks, see here, water flows or else enters through this inlet. While enters into the water will be flown, or else it's flown radially towards the tank. The gravity particles will settle at the bottom. From the bottom, through the sludge outlet, the particles will be taken out. What is we are discussing? Sedimentation. All the settled particles will be taken off from the water in the name of treatment. This is already we discussed in the previous class. Now we are entering into the next topics. I mean, in the same circular tanks. The second one is circumferential circular flow sedimentation tank. Circumferential. Okay. Water enters into the tank through this vertical slit, while this rotatory arm is fixed on the tank, and it is allowing the water to flow along the circumference of tank at a fixed low velocity. By allowing so, slowly the gravity particles, or else based on the weight, or else because of the weight, the particles will settle at the bottom and the clean water will be taken off. One more time. Circumferential surroundings. Water enter into the tank through the vertical slit, as the arm is fixed around the tank, and it is allowed to pass, or as to flow the water along the circumferences at a fixed low velocity. Here also the water flow is fixed. In this here also, how and why we are fixing the velocity? If the water is flow at speed, or at more than considerable speed, the particles may not settle. That is the reason the flow velocity will be fixed in such a way the particles will be settle on the bottom. By doing so, all the weighted particles will settle on the bottom, or else on the bottom, and the clean water will be sent out through the outlet. This is about the circumferential circular flow. You must, sure enough, all these diagrams, whenever you encounter this question, write your detailed notes on sedimentation, or else sedimentation tanks, rectangular tanks, circular tanks, and next one is hopper bottom tanks. Hopper, see, you're collecting at the bottom. Hopper means here bottom, hopper bottom, it's a funnel shape, or else settling particles from the bottom will be taken off. See here, water enters through the inlet and moves towards the bottom. Later on, its direction changes towards the top side of the tank. See here, what is the statement over there? Water enters. This is the inlet. water enters like this. This is in one direction. Once it reaches the bottom, it's the direction of water will change. See here, water enters through the inlet and moves towards the bottom. Later on, its direction changes towards the top side of the tank. As the water changes its direction, the sediments whose specific gravity is more than one will settle at the bottom, and the rest of the particles moves upwards along with the water. The settled particles will be removed through the sludge outlet pipe, and the rows of decanting channels. These are the decanting channels. Decanting channels are meant to maintain clean water on the, or else at the bottom, at the top of the tank. Depends here, and the clean water will be sent off through outlet. What is the topic here? Hopper bottom tanks. See here, through this inlet, water enters into the settling tank, whose bottom is hopper, funnel shaped. While the water is entering in this direction, the particles, or else the waste particles, or else the impurities whose specific gravity is more than one, will settles on the bottom as the water changes its direction towards the upside, or else towards the top end. See, as the particles are settled on the bottom based on the specific gravity, the remaining water will again move towards the top, and from here through outlet, the water will be sent for the next stage. Water will be sent to the next unit. Why these rows of decanting channels? These channels are meant to maintain clean water. It is a deflector box. This is called by name as deflector box, and it is sludge from here through the sludge pipe. From the beginning, we have been observing there is in a pipe, or else there will be a pipe. By using that pipe, the sludge will be taken off from the tank. We are discussing about sedimentation. What is sedimentation? Removing of particles. We have seen the technical definition also there itself. See here, settling of particles at the bottom of the tank or catchment due to the differences in specific gravity of liquid and solid particles. Settling of particles. Why? On what basis? Due to the differences in specific gravity of liquid and the solid and the waste particles in the water, or else the solid particles that lies, or else that is within the solid particles which are in that particular water. Differences in specific gravity of liquid and the associated solid particles. They are settling in the bottom. This is what about the sedimentation. See here, we have seen in the sedimentation, along with the definition, principles of sedimentation, design of sedimentation tank. There we have seen the inlet zone and what are the specifications we have discussed, followed by design of settling zone by adopting the formula L by V greater than H by Vs. Design of sludge zone. Here, this is the sludge pipe. As the bottom moves or is constructed towards center slopey manner, and it is attached to the sludge pipe, the settled particles will be taken off. Design of outlet zone, types of, and next one is types of sedimentation, or else different methods of sedimentation tanks, rectangular tanks, circular tanks, hopper bottom tanks. In rectangular tanks, we have seen the flow is fixed and the length of the water traveling is increased by keeping baffles at the sides of the rectangular tank, and followed by circular tanks, which has been divided into two types: radial flow 1.2 towards the, from the center towards all the direction, radial, and circumferential. Water will be sent into the tank along the circumference of the tank. Next one is hopper bottom tank. Water moves it's one direction and changes direction towards up. The specific gravity, whose specific gravity is more than 1, will settle at the bottom. This is about the hopper bottom tank. Now the topic is sedimentation with coagulation. In the sedimentation part, actually we are not doing anything, just we are allowing water without any disturbance. Based on the gravity, all the weighted particles will settle on the bottom and will from there will taken off. See here, sometimes the impurities may not remove, or is not sometimes, most of the times, all the impurities may not remove this sedimentation. They must remove, but they must remove from the water. See, in sedimentation practices, we have fundamental point is we are not creating any disturbance. See, if we allow settling those particles, especially which has the size of 0.6 mm, it takes 10 hours to settle in 3-meter depth of sedimentation tank. If the particle size is 0.2 mm, it takes 4 days to settle in plain sedimentation, which is practically highly impossible, because the load of water, or else the water is coming from intakes regularly. The received water from the intakes has to be treated and has to be sent to the public. If we are storing water like this 10 hours and 4 days, the demand of water to the public may not meet. That is why we need some alternative method. One alternative method is mandatory to remove all those fine particles, or else fine collided particles, by adding any coagulation, coagulant. What is this coagulant? What is this ABCD of coagulant? We'll discuss one after one. Understand? Here, sedimentation with coagulation. Why we need this coagulation? There in the hopper bottom, we have seen that all the weighted particles are settling on the bottom. Water in the sense, water from the intakes may not have the impurities which can settle on the bottom. There are other impurities also which we need to remove in the name of treatment. But in this sedimentation, we may not remove all the particles. That is why we have seen the flow chart at the beginning itself. We have seen flow chart of treatment works. See, plain sedimentation we have discussed. The next one is sedimentation with coagulation. That is the reason the particles which we were unable to remove from the bottom, as they are failed to settle because of the lesser weight, or else because of low weight. See, what is the weight? See here, what is the size? Weight in the sense size. If the size is 0.06 mm, it takes 10 hours to settle in 3 meters depth of sedimentation tank. In the same scenario, if we move further forward, if the particle size is 0.02 mm, it takes 4 days to settle, and we need to wait almost for 4 days for only sedimentation process. The sedimentation is the first step of treatment. There are a lot more steps to be conducted before the water is being sent to the public. That is the reason one alternative method is the mandatory, suggestible. What is the to trap all those unsettled colloidal, fine particles. How can we remove? Simply by adding a coagulant in the water. The coagulant will mix in the water. Because of the action of coagulants, all those fine particles will be trapped and it will be, or they will be removed from the water. What is the exact mechanism of this coagulation? We'll discuss in next class. Hope you understood about this sedimentation. So far what we discussed, that circular sedimentation tank, hopper sedimentation tank, of course, rectangular sedimentation tank. Now we also understood what is the need of coagulation also. In the next class, we'll discuss the next topic, associated topic. If you have any doubts, please contact the domain, whatever you feel convenient, either phone, message, or mail. Thank you.